or isosceles triangle. That all concepts we have seen. So, okay, I have give, and at last, I will not, on the last day also. So again, we are not going to take the important questions. Whatever the important questions are there, I am giving in the introduction itself only, and I am telling the what are the formulas useful for finding the problems also. So again, we will not go for the important questions. Today, we'll complete the other 3 blocks. We'll try to complete that. Almost second and third block will be completed. So what are the topics? Almost solutions are there in your textbook only. So try to practice those solutions. So if we have any doubt, almost in practical class also, problems will be only there. So whatever topics we are not able to cover here, you can cover them in the even practical classes. So if you know the concept, I am each and every concept I am explaining in the introduction only. With the help of that, you can solve the problems. Okay. So we have seen first unit and third unit in the block 1. They covered almost 30 marks. So in first unit, 1 10-mark question and 1 5-mark question you will get. And even in the third unit, you will get 1 10-mark question and 1 5-mark question. So in second unit, you may or you may not get the 5 marks question, but you will have the scope of first and second unit. You will have the objective type of questions. Okay. Third unit, almost you are not having any type of objective type of questions. First unit only 50% of the objective type of questions will be covered from the first unit itself. So many formulas are there, small formulas. So that are important here. So now today we'll go to the second block. In that we'll see the fourth unit. So the second block is about the lines. So if you'll see the block name, it is the straight line. Okay, we have seen the plane there in second unit and third unit. Block 2 is about straight line. So here in the straight line, we have unit 4 is about the straight line and various forms of the equation of the straight line. So you should know what is the equation of the straight line. So we all know how the line will be straight line. So for the straight line, we are talking this straight line in the 3-dimensional geometry. So that will have the equation in the form of x, y, z. Okay. So x, y, z coordinates will be there, and the general equation of the straight line. And you should know what is how we have seen in second and third unit, what is the general equation of the plane and also normal equation of the plane. If you know both of them, and in that what are the direction cosines and direction ratios, with the help of that, in this unit also we'll see the general equation of the straight line. General equation of the straight line is, the straight line is the combination of the two planes. Okay. So two plane equations, whenever we take it together of them, that is called as the equation of the straight line. Okay. So you can take it as ax plus by plus cz plus d equals to 0. If you write it is like this: a1x plus b1y plus c1z plus d1. Okay. So the combination of these two, this is one plane equation, this is one plane equation. When you combine both of them, this is called as a general equation of the straight line, and this equation is in unsymmetrical form. Okay. So one question on this also will be there. What is the unsymmetrical form of the line equation? Means combining of two plane equation is called as a unsymmetrical form. Okay. So whatever this two unsymmetrical form of the equation of straight line is there, when you convert them into symmetrical form, that will be in the form of like this: x minus x1 by L is equals to y minus y1 by m is equals to z minus z1 by m. So this is called as symmetrical form of the line. Okay. So that whatever the symmetrical form is there, how you got that? You have the in page number 100, you have the procedure is there in the textbook, and how you got the general equation of the straight line also, whatever the procedure is there. But for us, no proof or no procedure, they are nothing for us. Only problems will be asked. So you should know what is the plane combining of two plane equation in unsymmetrical form as called as a straight line, and here what is unsymmetrical form and what is the symmetrical form. So this is the main important one. So some problems will be given in the line equation in unsymmetrical form. So you should know how to convert them into symmetrical form. So one question on conversion of unsymmetrical to symmetrical. It is a 5-mark question you will get. So with these two, so two plane equations are there now. From the two plane equations, we have to find LMN values. Okay. So how you will get this? If we'll take these two plane equations as perpendicular to each other, we'll get we have to find ABC values. So from that ABC values, you'll get it. So that procedure is there in your textbook. If you find LMN values from these two plane equations and also X1, Y1, Z1. So how you'll get X1, Y1, Z1 means if you solve these two plane equations, you'll get X1, Y1. And for solving this, for getting X1 and Y1 value, you have to put Z value as 0. So when you put Z value as 0, you'll get X1 and Y1 values, and another Z1 value will be equal to 0. Okay. So when you'll take that procedure, you'll find LMN and also X1, Y1, Z1. When you substitute in this one, you will get the symmetrical form. So you have the example problems on this, and this is, and in block 2, 4th and 5th units are only 2 are important. In 4th, you will get 15 marks, and 5th unit, you will get 15 marks. That is 30 marks you will get from the block 2 itself only. So 6th unit, no question is given for the 5 marks or 10 marks. Even objective type also you will not get in the 6th unit. There is a change of axis is there. It is not considered, almost the topics are not considered in the question paper pattern also. Okay. So block 4 and block 5, if you are perfect with them, you can easily score the 30 marks. Okay. So that is, you will get the 10 marks question 1 and 2 5 marks questions. So 10 10 means 20 marks. And you have the scope of getting even 10A and 10B questions from the 4th and 5th unit only. Okay. So conversion of unsymmetrical to symmetrical form. This is 1 5 marks question you have. Okay. So after that, that conversion is also there in your textbook, and how the line equation will be there. It is given in one page number. Example is given. If it is in not the symmetrical form, you can convert the given line equation into symmetrical form also. So after that, here 103 page number, you have transformation from unsymmetrical to the symmetrical form. So two plane equations are there. So from the two plane equations, if you will take the direction ratios, so the direction ratios are A1, B1, C1 and ABC. So from that, if you solve those two, you will get the ABC values. So that ABC values are whatever in the denominator are there. So here, this LMN are the direction cosines in the line equation, and instead of these direction cosines, you may have ABC also. So here these are direction cosines. Okay. Even line equation in symmetrical form, instead of L, you will have like this also. So these ABC are direction ratios. Okay. So like this form or like this form, both are the symmetrical form of the line equation only. If you have in the denominator LMN, then they are direction cosines. If you have ABC, then they are the direction ratios. So on this only, you have page number 103, 4.2.4, how you transfer unsymmetrical form to symmetrical form. So procedure is there. First, you have to find ABC values. Then we have to find the X1, Y1 and Z1 values. If you'll see 104 page number, example is there. Find the symmetrical form of the equations of the line. Line equation is given, two plane equations. From that, you will get the ABC that as a perpendicular to their normals, means instead of XYZ, you have to substitute ABC. If you substitute ABC, you will get two plane equations. If you solve those with the help of the cross multiplication, you will get ABC values. And for getting XYZ values, in the two given plane equations, you have to substitute Z value as 0. So you'll have only X and Y values. If you solve those two, then you'll get X and Y value, and Z value is always 0. So if you substitute them in the standard line equation, then you will get the equation of the line in symmetrical form. So if you know this procedure is useful for other units also, conversion of unsymmetrical form to symmetrical form. Okay. So this example 104 example, this is the repeated question. And even page number 105 example is there, no? Find the equation of the line through the point. This is also important one. Okay, these two are the 5 marks questions. And check your progress is there, no? First question, find the symmetrical form of the equation. So same procedure, if you follow, you will get the same answer. Next one is angle between a line and a plane. So line means this is the equation of the line. Plane equation means, you know, ax plus by plus cz plus d equals to 0. So between a line and plane, to find the angle between them, you have the formula, that is ax plus, okay, this is one equation, this is 2. So angle between 1 and 2. That is, one is line and second one is the plane equation we have. So you will have the angle as like this, cos pi by 2 minus theta is sine theta. That is, means we are converting it into sine theta. So this is whatever the direction ratios, the direction cosines, and here direction ratios. Combining of them, AL plus BM Cn by under root of a square plus b square plus c square under root of L square plus. Okay. So this is one 5 marks problem you will get on this topic, angle between line and plane. Okay. So on this, I have given the formula. Just if you, these two equations will be given in the question, you should know just LMN values and ABC values. If you substitute in the formula, you will get the angle. So that you will get for 5 marks. 106 page number, you have example 4.3.2. Next, check your progress also. You have the third and fourth question. In fourth question, what it is there means, instead of the plane, instead of the line equation, directly he has given the direction ratios. Okay. So just if you substitute LMN and A and B and under root of that one, you will get the, okay, this last you are not able to see. Okay, this formula is AL plus BM plus CN by under root of A square plus B square plus C square. Okay. And then this is L square plus M square plus N square. This is the formula. Okay. If you substitute the values in that, then you will get the angle between the plane and line. This is the one topic you are able to get for the 5 marks question. Next, we have point of intersection of the line with the plane. So one line equation will be there and also one plane equation will be there. From these two, what is the point of intersection of the line and plane? So on that also we'll get one question. You have the example on 108 page number. Okay. Next main important, that is a 10 marks question in this unit, is about the coplanarity of the lines. This is the main important one. Coplanarity condition of coplanarity, we can call coplanarity of lines. Condition will be there. What is the condition means, you should know the formula. Coplanar lines means, okay, so two line equations will be given, that is x minus x1 by L1 is equals to y minus y1 by M1 is equals to z minus z1 by N1. Okay, this is one line equation. And next one is second line equation is x minus x2 by L2 is equals to y minus y2 by M2 is equals to z minus z1 by N2. Okay, these two are the line equations, and the two line equations, when they are called as a coplanar, means when these two line equations, whatever the formula is there, that is when you find the determinant of that one, when it is equal to 0, then the formula for that is the determinant of x2 minus x1, x2 minus x1, y2 minus y1, z2 minus z1 L1, M1, N1, and L2, M2, N2. If you're getting, after finding the determinant of this one, if you're getting the value as 0, then the two lines are called as a coplanar lines. Okay, this is even, it is the 10 marks question. Okay, so 10A question you will get for the coplanar of lines. And what is the condition of coplanarity? So the condition of the coplanarity is that whatever the points are there in first line and second line, that is x2 minus x1, y2 minus y1, z2 minus z1, and in the denominator, whatever the direction cosine values are there, if you substitute, and I hope so in the matrices you have the idea of the finding the determinant. So if you find the determinant, if you are getting the value as 0, then the two lines are called as coplanar lines. If you are not getting the value as 0, then the lines are not coplanar. Okay, so and for this is the half part, and second part will be, he will ask to find the equations. So what is the required equation of the plane containing these two lines? What are the equations means? For that you will have the formula x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2. If you equate this one to 0, and if you find the determinant of this, you will get the equation of the plane containing the line. Okay. Next, the second one is x minus x2, y minus y2, z minus z2, L1, M1, N1, L2, M2, N2. So you will get here two equations, and you will get here condition. If you solve, if you know these formulas, it's enough for this one. So when you substitute all the values, if you are getting 0, you write here down that given two lines are coplanar. And for finding the equations, if you substitute the values in these two, and if you do the determinant of that one, you will get the equations. So this whole combination of this is for 10 marks, and it is about the coplanar lines. And same, this procedure only will be there even if we ask in the question, instead of coplanarity, if he is asking intersection of the two lines. Okay, intersection of the two lines also, if you get here equals to 0, then the two lines will intersect each other, and in that only he will mention even finding the equations. And in one more addition will be there, if he's asking intersection means what is the point of intersection, at what point their two lines are intersecting. So that point of intersection also he will ask. So if intersection is asked, whether they are intersecting or what are the equations, and to find the point of intersection. 3 will be there. If it is a coplanar means whether they are coplanar, and also find the equations. So you may get the question for coplanarity or intersection. The procedure is the same one, and you will get for it for 10 marks. Okay. So if you'll see in 111 page number, you have the formulas here. Whatever formula is there, that is therefore the condition is clearly satisfied if the lines are parallel. Okay. Here after 5th and 6th equation, which is the required condition for the lines to intersect. Okay. So after that, if you substitute in the equations, which is the required equation of the plane containing two lines. So here two equations, whatever I have told there, if you see the example, it is in the page number 112, page number 2 line equations are there. Show that they are coplanar, or find the equation of the plane containing them. Okay. If you do the substitute in the determinant of this one, and this one, you will get the two plane equations. Okay. So this is the one problem, such type of problem. If you'll see in the check your progress also, you have same one. See, show that the lines intersect and find the coordinates of the point of intersection and the equation of the plane containing them. Okay, so you can see these two example problems. And the same, what will happen means some type of questions will be there in which these two line equation will be not in symmetrical form. Just now we have seen unsymmetrical form, no? That is two plane equations. So two plane equations will be given, and from the two plane equations, he will ask to find that whether the two, that is plane equation 2 means it is a combination of a line equation. So that from the means 4 plane equations will be there. Combination of 2 plane equations is 1 line equation. So 4 planes will be given. From the 4 planes, he will ask to show that whether they are coplanar, and also find the equation containing them. Okay. So for that, one direct procedure will be there, or else you can convert those unsymmetrical form to symmetrical form, and then you can directly put them in the this whatever formulas are there. Okay, that procedure also you have in your textbook. Worked out exercises are there, no? So once you see these problems, just if you have time, you can see them. Next, 119, page number 4.8.8. So prove that the lines, see, one is in symmetrical form and another one is in unsymmetrical form. So you can convert the unsymmetrical form into symmetrical form, and you can find the, we can show that whether they are coplanar or not. Or else one more method will be there. In this problem, he has given that method by combining those two planes with the help of lambda. And if you find the lambda value and if you substitute in the, then you can find if you are getting the value as 0, same after substituting, if you get the value as 0, then you will get the, they are coplanar, and from that only you can find the, what is the equation also. So you can see the procedure when one is in symmetrical form, another one is unsymmetrical form. Or else if you have any confusion, whatever unsymmetrical form plane is there, that you convert into symmetrical form and then directly substitute in these formulas. You can use any one procedure. Okay. Next, 120, page number only 4.8.9. If 4 plane equations are given, so in that case, how to find the problem? That is given here, solution. So in this textbook, he has given unsymmetrical forms. He has converted into symmetrical and he has substituted in these formulas. Okay. So that problem is important. And after this, if you'll see the model examination questions. So in this only, their example problems and also here model examination questions, whatever the problems are there, those you will get for the 10 marks one. Okay. 125, page number, 4th question. Okay, 4th question is for only 5 marks question it is. Next, 6th question, intersect is there. Find the point of intersection and equation of the plane. And also 6th, 8th, 9th, 6th, 8th, 9th question. And even you can see the 10th question. Okay. So from this question, you will get one 10 marks question. If you know the procedure, you can do any problem given. Okay, this is about the 4th unit. Next, we have about the 5th unit. 5th unit is about the skew lines and finding the shortest line segment. So this is important. So same line equation will be there. Skew lines means skew lines are called as two non-coplanar lines. Okay, two non-coplanar lines which do not intersect are called as skew lines. Like this you will have, which are not parallel and also which are not intersecting. Such type of lines are called as skew lines. And here for the skew lines, we are finding the shortest line segment. And this is whatever we are seeing the topic, that is the about the 10 marks question. Okay, shortest line segment, you will have formula. So shortest line segment. Okay, same here you will have the two lines, x minus x1 by L1 equals to y minus y1 by M1 is equals to z minus z1 by N1. This is one line equation and this is the second line equation. So from the two line equations, we have to find the first thing is we have to find the shortest line segment between the two lines. Length of the shortest line segment, the question will be find the length of the shortest distance between the two line segments, and after that find the line equation will be there. Equations we have to find. So two line equations will be given. From the two line equations, you have to find the length of the shortest distance. So length of the shortest distance formula is length of shortest distance, that is the shortest line segment is, formula is, it is equals to L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. Okay, if you substitute in this formula, you will get the some value you will get. That value is called as the length of the shortest line segment. Okay, and these LMN values you will get from this L1, M1, N1, L2, M2, N2. Okay, the procedure, whatever is there in the textbook, it is in the page number 129, it is there. The proof is the given, length and equations of the shortest line segment, how to find them. L into L1 plus M into M1, and if you'll do the cross multiplication, and with the help of solving, you will get LMN values, and substitute those LMN values here, and X1, Y1, Z1 are the points here, X2, Y2, Z2. Here if you substitute them, all you will get the values, no? So when you simplify, some value you will get here. So that value is called as the length of shortest line segment. And to find the equations, we have the formula is X minus X1, Y minus Y1, Z minus Z1, L1, M1, N1. Here you will have LMN values. Okay, here also LMN values, almost coplanar, and this you will have the same formulas, but instead of L2, M2, N2, you will have LMN. These whatever LMN values are not these two, these. Okay, LMN values you will get from the starting doing the procedure. So that values, if you substitute and equate to 0, you will get 2 equations, and here you will get the value. So the combination of this whole thing is the 10 marks one, and compulsory, this is the every time in any series you will get this one in any examination, not only this, even in the supplementary examination also on this topic you will have compulsory 1 10 marks question. Okay, this is about the shortest line segment, and this whatever finding the shortest line segment and finding the equations, for this you have 3 methods are there. Okay, not only this method, you have second method is there, third method is there. So by using any one method which is applicable to the given question, okay, some question you may have in symmetrical form, some questions you may have in unsymmetrical form. Whenever it is in the unsymmetrical form, you can use the second method. Okay, third method almost it is applicable to even symmetrical and unsymmetrical also. Okay, first method almost it is for symmetrical. Whenever second method is there, it is for unsymmetrical form, and third method you may use by seeing the question itself. Okay, that 3 methods are given in the textbook. See for the problem 130 page number, if you'll see 5.2.2, whatever the example is there, for this example first method is there. Okay, second method is there, combining of those two. For only symmetrical form only we have shown. Second method is there, even third method is also there. Okay, so you can use any method for solving the problem. If you'll see 134 page number, example is there, 5.2.3. So from this you can know how to find the shortest line segment and equations. So this is one 10 marks problem in this. And another one important one is finding the nature of intersection of the planes, intersection of 3 planes. If 3 planes are given, how to find the intersection of these 3 planes? That is, this is one 10 marks question, and this you have example problem, and also from the MEQ questions. So that is a last, after completion of the unit you will have, no, from that also you get the questions. But the procedure you have to understand here. Next one is nature of intersection of 3 planes. So in this, so 3 planes, and the planes will be like this: A1x plus B1y plus C1z plus D1 equals to 0. Next, A2x plus B2y plus C2z plus D2 equals to 0. Next, A3x plus B3y plus C3z plus. Okay, these are the 3 plane equations. So you have to find the intersection between these 3 plane equations. For that, the procedure is first you have to find the delta. So delta will be the coefficients of all the plane equation, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, this is our delta, and delta 1 and delta 2 means Here delta 1, delta 2, it is given in the textbook. You can see delta 1, delta 2, delta 3. If you have the idea about intermediate, you have the Cramer's method is there, no? So that is instead of any one here column, you have to write D1, D2, D3 values. If you write here first one column as D1 and D2, D3, you will get the delta 1. If you write the second column, you will get the delta 2 values. That formula is also given here. See. So delta 3 is, if you'll get here this one, instead of C1, C2, C3, if you write delta 1, delta 2, delta 3 means delta 3 value. Delta 1 means here instead of this one, this is delta 1, delta 2, delta 3. Next one, B1, C1, B2, C2, B3, C3. This is delta 1. This is A1, A2, A3. Here D1, D2, D3. And here C1, C2, C3. Okay, determinant of this one. Here A1, B1, A2, B2, A3, B3. Next D1, D2, D3. That is in place of this. If you write, you will get delta 1, delta 2, delta 3 values. Delta is just the coefficients of X, Y, Z. Okay. So by this, you will get the all the values. So 5.4.1, you have the example is there. From this example only, almost you will get the, this is the 5 marks question. So 10 marks question is the shortest line segment and 5 marks is this one. And the conditions will be there. That conditions are important when they are intersecting the three planes, what type of figure you are getting when they are intersecting. So if delta is equals to 0, if you are getting the delta value as 0, and whatever delta 1 and delta 2, delta 3, if you are not getting, that is delta 1, delta 2, and delta 3. If you are getting the values as some values not equal to 0, then one prism will be formed. Okay. So first thing is delta should be equal to 0, and other whatever delta 1, delta 2, delta 3 values should not be equal to 0. Then they whatever the planes are there, those Okay, students. Okay, due to power cut. So in the middle, you have got the disturbance. Okay, now we are continuing the video. So here we have seen the word delta. So delta values are the coefficients of the three planes. So if delta value, whatever is there, if you are getting 0 and delta 1, delta 2, delta 3 values, means you are getting some values other than 0, then whatever the three planes are there, those three planes will form a prism. Okay. And the second condition is if you are getting the delta value as 0 and other three values, even delta and delta equals to 0 and delta 1, delta 2 and delta 3 values, all zeros. If three values you will get the 0 means they will intersect in a line. Okay. They intersect in a line. Intersect in a line. Okay. And if in the starting itself only, if you'll get the delta not equals to 0. If delta not equals to 0 means the plane intersect at a unique point. Okay. Intersect at a unique point. At one point only. Intersect at a unique point. So when you'll get delta not equals to 0, no need of finding delta 1, delta 2 and delta 3. Okay. So this is a one compulsory 5 marks question. So if you know these formulas, then any problem given, three plane equations are given, then you can find the solution for this one. Okay. So this is the main important one. So in block 2, fourth unit, I have told symmetrical and unsymmetrical form, that is a 5 marks question, and one is a coplanarity and introduction, that is a 10 marks question. And here straight line, if you will see the shortest line segment, that is a 10 marks question, and nature of intersection of the plates, this is the 5 marks question. Okay. So these topics are the important topics. In block 2, if you are perfect with these 2 units, it's enough. Okay. So the example problems are 140 page number, you have 5.4.1. Next, in check your progress, you have the third question, it is there. This is also important one. So see some worked out exercise. Any problems are there related to these topics, you see them. Next, in the MEQ, that is a model examination questions. If you'll see 150 page number, fourth question and the third question. So these are the 10 marks question, third and fourth, and 10 and 11. Okay. So 10 and 11 are, these are the very repeated questions. Almost they are, these two line equations are in the unsymmetrical form. So for the unsymmetrical form, you have to find the shortest line segment. Okay. These are the topics you have. Next, 152 page number, you have 21 question. It is the 20 and 21. Examine the nature of intersection of the plane. Just now we have seen the concept. No, on that concept only you have these two questions. Okay. So by this we are completing the block 2. So next we'll go to the block 3. It is about the sphere. So on sphere also, it's every block, you know, 2 10 marks questions and 2 5 marks questions you will get. So about, it is about the sphere. So sphere here important is we have to know what is the equation of the sphere. If S is a sphere which is equal to 0, so the equation of the sphere is, or else we call it as a general equation of the sphere. So how you will get the equation of the sphere? That concept you have here in 179 and 180 page number. Okay. So just we are knowing what is the equation of the sphere. It is x square plus y square plus z square plus 2ux 2vy plus 2wz plus d equals to 0. Okay. This is the equation of the sphere. And the center for this one is, center is equals to minus u minus v minus w. And the radius of this sphere is under root of u square plus v square plus w square minus d. Okay. So 4 points will be given. And from whatever the points are given, that 4 points you have to substitute in this equation of the sphere. This is called as a standard equation of the sphere. If you substitute these points, you will get the 4 equations. If you solve those 4 equations, you will get u, v, w. So if you get u, v, w, if you substitute them in the radius, okay, from this u, v, w and even d value also will be there. If you substitute all values in this formula, then you will get the equation of any sphere passing through these 4 points. Okay, so directly 5 marks question means how they will give ask means directly the equation of the sphere will be given in the question, and he will ask to find the center and radius of the sphere. Okay, that is a 5 marks question. If he is asking to find the equation of the sphere which is passing through the 4 points, that is a 10 marks question. Okay, 4 points will be given. So the sphere which is passing those 4 points, you have to find the equation. So that one you will get from substituting the 4 points, each and every 1 point. If you have like this 4 points will be there. So each point you have to substitute, you will get 1 equation. Second point, third point, fourth point. So you will get 4 equations. If you solve any of them equations, you will get u, v and w and d values. After getting those, if you substitute here, you will get the equation of the sphere. From that sphere, you can eliminate what is center and what is radius. Okay. When you equate this getting equation to this one, you have to find the u, v, w values and what is the radius. If you know these 2 formulas, it's enough for us. So this is one 10 marks question to find the equation of the sphere, and to find center and radius, it is the 5 marks question. So you have the chance anyway, either equation of the sphere they will ask, or they will ask to find the center and radius. So whole topics you have here on this 182 page number. If you'll see, example is there 7.2.3. Already sphere equation is given. From that you have to find the center and radius. So this is the 5 marks problem. So try to solve with the elaborating the solution. Directly don't write what is the u, what is v, what is w value. So just you convert that into the standard form. How is procedure is given in the textbook. Try to write somewhat lengthy one for 5 marks. Okay, then you will get the full marks. And 183 page number only 7.2.4 example is there. So 4 points are there. See 0, A, B, C. So how you are getting the equation of the sphere. And in page number 185 page number, you have the radius. Find the radius and center of the sphere. Check your progress. This is also one example problem for 5 marks. Next, we have the concept of the plane section of a sphere and intersection of 2 spheres. So plane section of the sphere means from the sphere, if any plane is passing through like this. Okay, this is called as a plane. Either you can take as like this ax plus by plus cz plus d equals to 0. And this is the equation of the sphere. Okay, so that plane section of the sphere, you have the formula will be there. So the combined equation of a plane of a sphere, this is the sphere and this is the plane equation. So either this, or you can take even lx plus my plus nz equals to plane. So any one equation, either this equation or this is the general form, this is the normal form. Okay, so plane equation and also the sphere, combination of these 2 is called as a plane section of a sphere. Okay, plane section of the sphere, and the formula is SC plus delta into P equals to 0. SC is here sphere and this is the P is the plane. When you combine these 2 of them, this is called as a radical plane section of sphere. Okay, so wherever you will get these 2 combination, you can see them and you should know this formula. So that is only concept given here. Next, circle. So combination of sphere and plane is called as a circle. Okay, so from the sphere only, if you take the combination of this sphere and also plane, then we call it as when a plane cuts the sphere, then one circle will be forming. Okay, that's why we call the combination of sphere and the plane as a circle. Okay, so 186 page number, even you have the intersection of 2 distinct spheres is a circle. So distinct in the sense 2 different spheres is the when they are intersecting, that whatever the portion is there, that is called as a circle. And you have the equations here. Next, 189 page number 7.3.5 example is there, no, find the equation of the sphere passing through the circle. So here one sphere equation is there, x square y square plus z square equals to 9, and another plane equation is there, and one point is given. So when you first this formula you have to apply, s plus lambda into p equals to 0. To find that lambda value, one point will be given, that point substitute in that one, so you will get the lambda value. If you substitute your lambda equation, then you will get the equation of the circle. Okay, this is one 5 marks problem you will get. So this is the topic here important in this. And next to 193 page number, model examination question. So in this almost only plain section topic is there, no, only that topic you will get for the 5 marks question. Find the center and radius of the spheres, first and second one. Okay, this is the 5 marks question. So almost this is only. Next we have the in block 3 important one is tangent plane. Okay, what is the tangent plane? Tangent plane, normal plane, and polar planes of a sphere. Okay, these three are important. From this you will get one question for the 10 marks one. Okay, before the tangent plane and tangent line, so if you know the concept and the formula of tangent plane, so you can solve the problem. So if any one sphere is there like this, so at any one point, from the point here B, if a line is passing through this sphere, okay, through this whatever the point it is passing, if you take that point as P, and from here line is passing from point B, one line is passing on the sphere by touching the sphere at one point. That point, if it is passing, that line L is called as a tangent line. So L is called as here tangent line. Here this is one point, and here it is meeting, or here it is touching at one point. That is called as a tangent line. And the path, whatever it is making, the line which is making the path on the surface of the sphere, that path is called as a tangent plane. Okay, tangent plane. We denote it as phi. Okay, so whatever the path it is making on the sphere by touching at the point, that path is called as a tangent plane. And that if you see, you have the same concept. So that concept you have as in 8.2.1 definition. Okay, if a line L through the given point B has only one common point, that common point is T. Okay, so next the concept is about 96 page number. You have the length of the tangent from a point P to the sphere S. One point is there P, one point is given and one sphere is given. So to find the length of the tangent, so this is root S11. Okay, so you have to remember this formula. This is even objective type also given, or else on 5 marks question also you will get. So S is the sphere. Okay, x square plus y square plus z square plus 2ux 2vy plus 2wz plus d. Okay, next if we'll take S11 means one point will be there, x1 y1 z1. So that point you have to substitute here, then we call it as S11 sphere. That is x1 square plus y1 square plus z1 square plus 2ux1 2vy1 2wz1 plus d. So this is, if you do the root of this one, that value is called as the length of the tangent. Okay, so that is only the concept of 196. So this is also important one. If we'll go to the tangent plane equation, here we have the equation of the tangent plane. Equation of tangent plane is, we can write even it as S1. S1 is equals to x into x1 plus y into y1 plus z into z1 plus u into x plus x1 plus v into, not able to see, no? Plus v into y plus y1 plus w into z plus z1 plus d equals to 0. So this is the equation of the tangent plane that you have in 197 page number. From the last third equation is there, no? That equation. Okay, This is called as S1. Last also you have S1 is equals to x(x1) y(y1). This is called as the equation of tangent plane. So on tangent plane also you will get the problem. Any plane on this, whatever we have seen the path, any plane on this above, this is called as path, whatever it is formed, this is called as a tangent plane. Okay. So formulas you have here in 198 page number note is there, no? There you have the formulas are there, and you have the concept of when two spheres are touching each other internally or externally. So what is the centers? How they that is a third point is there in note. R1 and R2, if they are equals to AB, then they touch externally. If you have the R1 and R2 less than 0, then the condition is there. In the case P divides AP internally in the ratio R is to 2. Okay. So if mod of R1 minus R2 equals to AB, they touch internally. Okay, the concept you have in the 8.2.5. This also you may get for the objective type of question. Okay. So next 199 page number, if the spheres S equals to 0, S dash equal to 0, touch at a point, then the equation of common tangent plane. Equation of common tangent plane is S minus S dash is equal to 0. Okay. So on that example you have down. So 200 page number example is there 2.2.8. This is find outing the equation of the tangent plane. Okay. Next one is the main in this topic is about the pole of the plane. Okay. Pole of the plane means from the point from where the point it is touching the sphere, that point is called as a pole of the plane. Okay. So for that you have the formula is there. This you will get for the 5 marks question, pole of the plane. So on page number 204 you have this is LR square by P is equals to MR square by P comma NR square by P. This whatever the coordinate is there, this is called as the pole of the plane. Next polar of the plane also will be there. Before that you have the page number 205, conjugate points or conjugate lines are there. Okay, 2 points will be there. If you substitute those 2 points with respective of the sphere, so if you get the same one, then the 2 lines are called as a conjugate points. You have example on 208 page number. 2 points P and Q are there and one sphere is given. First you have to substitute 1 point, then you will get one equation. Okay, polar plane and tangent plane both are almost, their formulas are same only. Okay, so you will get one equation. In that equation, if you will substitute the second point, you have to get the value as 0. And similar way, second point you have to substitute, you will get one polar plane. If you substitute the first point, you will get the equal to 0. Then the 2 points are called as conjugate points. So that example you have on 8.3.30. Okay. Next you have the topic of angle of intersection of 2 spheres. So this formula is important. So 2 spheres, if they are intersecting like this, the common point will be here P and here 2. This is the C1 center of the sphere. This is S2 and this is the C2 center of the sphere. You can take here A, B, one triangle you will get here. It will make the angle theta, and this is the R1 and R2. Okay. When the intersection of 2 spheres are there, so to find the angle between those 2 spheres, that formula is cos theta is equals to plus or minus. You remember this formula with the help of, no need of the proof. Just if you know the formula, it's enough. 2 R1 R2. Okay. Even you may get for the objective type also this is. Here C1, C2. Sorry, don't write AB. It is a C1, C2 center. Here almost it will be in the center only. So this is C1 and this is the C2. Center of the sphere C1 and radius of this one R1. Center of the sphere C2 or radius is R2 and theta is the angle and they are meeting at the point P. Okay. So then the formula is this one. And another one is the necessary and sufficient condition. This is the important one, 210 page number you have. The necessary and sufficient condition for the 2 spheres to cut orthogonally. The condition is 2 spheres will be there. If they are cutting orthogonally, the condition is 2u1 u2 plus 2v1 v2 plus 2, able to see here. So 2u1 u2 plus v1 v2 plus 2w1 w2 is equals to d1 plus d2. This formula you have to remember. On this you will get, okay, you may have even this as just u and u1 in your textbook. It is given as like this, u into u1 v1 1 1. Okay, instead of 1 and 2 he has taken only u and u1. Okay, so this is the formula you have for the if they cut the orthogonal. Okay, so after that 211 page number you have 8.4.4. That is a theorem you have. This is also 111 marks question you will get. Next 212 page number 8.4.6. This example problem also you see. Next 214 page number 4th question. This is also 10 marks question. Okay. In the 9th unit we have the concept of radical plane. Radical plane ante similarly it is s minus s dash equals to 0. Okay, on this also you will have the formulas. Problems will be there. Okay, you see them. Next coaxial system is there. Coaxial system means s plus lambda into s1 equals to 0. Okay, two spheres if you combine with them lambda, then that is called as a coaxial system. And also the topic about limiting points, this is also there. So these are from this any one topic you will get the 10 marks question and 1 5 marks question. 223 page number limiting points is there, 7th one, and 9.3.6 you have the definition. And 224 page number 9.3.8 example 10 marks one. 9.3.9. Okay, it is also 10 marks question. Next 227 page number 7th question, find the limiting points is there. It is also the 10 marks question. Okay, so by this we are completing the block 3. So next class we'll see the block 4. It is about the cone and cylinder. Okay, so in that also we'll see what are the important questions for 10 marks and 5 marks. Okay students, next class we'll see